we go. Tomorrow. I have no idea how many questions or how many points at this point. It doesn't matter. All right. So do we know the material on it or not? Hills and Sass. You're going to look at a problem tomorrow, and you got to decide where to go. Hills and Sass, Pythag, or your special right triangles. What should the diagram look like if it's a Hills and Sass problem? Well, first, you're going to have a big right triangle, right? All right, what's going to be contained in that right triangle that automatically signals, darn right, I'm doing Hills and Sass, no other options? Zach? No. Altitude. Get more specific. Where should this altitude be drawn? Scott? Correct. So I should have a line segment that is perpendicular to the hypotenuse. This is Hills and Sass, everybody. All right, let's review it. Hills and Sass. B, C, A, D. We already gave this away, so I won't ask anybody. This is your altitude. What do I call BC in Hills and Sass now? What do I call side BC? That's called a... Should have set this up earlier. One job. Eight. What do I call BC? Leg. Yeah. A leg. So's BD. What's AD called in this? What do we call AD? 3? From Hills and Sass. What do we call that? AD. Segment. And that's what we also call CA. And the final thing I'm asking for is, what do I call CD in Hills and Sass here? What's CD referred to as? Oh, one. Darn right, hypotenuse. So everyone all right of the different parts? Next, I'm not even done with Hills and Sass. Talk to me about Sass. Talk to me here. What pieces go in for what? Okay. Well, stop. Sorry. S.
The segment.
A.
Altitude.
A.
Same altitude.
S.
Segment.
Which one though? Same one I put here or different one?
Adjacent.
You're thinking about
The same
hills.
one.
Remember, Stella, these are always the same. Whatever you put here is always different. So the altitudes, the numbers you put here for the altitudes are the same. These are two different segments. Good? Two different segments. We all right? Okay. Talk to me about hills now. What's the story here with hills? 16. H?
Hypotenuse.
Correct. L?
Leg.
L?
Other leg. Or the same leg.
Same leg. S?
Segment.
Where? Which one?
Segment adjacent to the leg.
Correct. Are we all good? I gotta have that diagram. Maybe it doesn't look like this. Maybe I turn it. Who knows? But I need a right triangle with an altitude to the hypotenuse. Hills and Sass. Don't make up Hills and Sass on your own. I need that diagram. Questions? Pythagorean Theorem. Always an option tomorrow, right? If you have two sides of a right triangle, trying to find the third. But remember the other use for it, because I'm going to quiz you on it tomorrow. The other use for it. What do I mean by that? Well, if the a squared plus b squared side is equal to c squared, it is a right triangle. What if the a squared plus b squared side is bigger than c squared? This is a acute triangle. And then finally, the only other option is the c squared is actually bigger. And this would be obtuse triangle. So there is one little small question on there about acute, obtuse, right? Using Pythag. Just don't forget about Pythag. Everyone's so into Hills and Sass and the special triangles that we always forget Pythag. If you have two sides and you need a third, Pythag might be your go-to. Yeah. Any questions there? Whew! Your 45, 45, 90 rules. I'm not going to give them to you. What do we know about the legs? And how do I find the hypotenuse? Leg times square root 2. Questions? And 30, 60, 90. Tell me something about the hypotenuse. Two times the, where's the shorter leg located? Across from the 30, yep. Longer leg is where? Across from 60, and how do I find it? And I just had a quick reminder, don't round until the end of a problem, okay? Don't round to the end of the problem. If you have a decimal answer that you need to figure out the final answer, don't round it. Don't round until the end. And I'll leave you with one other piece of advice before you get going on your own. Do not add in angle measurements that aren't there. Okay? Do not add in angle measurements that aren't there. Here's what I mean. Say we have a student who doesn't study. It wouldn't happen in here. And they get, this is an easy one, but say I gave them that. This is obviously a Hill-Sass question if you've done your work. But some people may not notice that, and I'll get, oh, that's 60, that's 30. How do you know that? How do you know that? You know what? You don't know that because it's false. Do not add in angles on your own. We all good? If you're adding in angles on your own, you just don't see it. Okay, that it's probably Pythag or Hills or Sass. Everybody all good? Do not add in your own angles. Unless you are sure, unless it's something like, if I have an equilateral triangle, anybody remember what all the angles are? 60, okay, now you can put that in, sure. All right, but if it's just a diagram like this and you're just plopping in your own angles, nope, you're doing something wrong. Questions? All right, look, I'm done. You got to practice. So before you start, all right, I rarely do this for a quiz, but I think it's that important and that tough. You have the day 6 problems right here in your packet. On top, some textbook questions to try. Highly recommend those. And up on Classroom, not yet, but there will be once you start, I am going to put an extra review that covers Hills and Sass and a lot of Hills and Sass if you want practice there, and your special right triangles. Okay? This is rare for a quiz. You have all this to choose from and work from, but that's how seriously I'm taking it here. Okay? So I'm going to put this on Classroom under Unit 8. So you guys pick and choose where you want to go, but have the darn answer key out, please. All right, can we have the answer key out? That'd be great. So you know what you're doing is correct. I don't care who you work with, but you know you got a job to do tomorrow. So you might want to, pick your poison carefully. All right, let's get going. Call me over if you're just stuck on a question. Sure, Luke, go. I'll put this on Classroom, and then you guys have 3 different avenues to practice. Before you start a problem, am I going to use Hills, Sass, Pythag, 30, 60, 45, 45, 90?